My name is Eoin Brazil. I'm a team lead in MongoDB. I'm going to talk a little bit today about something I learned a lot of over the last year, observability. There isn't going to be huge piles of code in this. I'm not going to be as brave as the last speaker to try live demos. They never work for me. Congratulations. They always are a tire fire for me. What I am going to talk about is some of the learnings I had when I inherited a Python stack, and thankfully the applications around it were very successful, so I needed to do more and add more different instances. Sadly, in doing that, it became really hard to figure it all out. So that's really today's sort of thing. I hope you'll learn something from my bouncing off the wall, hitting my leg, hitting my head, hitting other body parts, trying to figure out how things work and broke. I want to just point out one talk from Pycon, not here, another Pycon by Lynn Ruth. It gives a good starter to the whole topic of observability. We've moved to a period where once upon a time you used to have a web server and your Python application and your web browser, and that was the stack. People would query from that web browser, it'd go to the web server and it'd go to Flask or Django or whatever. You could kind of debug that. Sadly, that doesn't really reflect a lot of today's software, and it particularly doesn't reflect it as we start to talk about microservices. You end up with a load balancer, maybe more than one load balancer. Your request could be serviced by a couple of different front-end processes, even more back-end processes. Hey, let's throw in some third-party services. We want the party parrot embedded in our page. We have a cache for some of this stuff at various points, and we have a database or several there. So one of the things observability is based around the premise of helping you debug these complex systems, giving you an understanding of the system from the inside out. It'll talk a little bit about white box and black box later, but it's really to help you as a developer, software engineer, get some insight into all of these components. If we look back at the Django demo, we saw a request come through, and you probably saw the post, the get and the post. When we move that up, if I have 20 customers at one point, how do I track back which one was the one who looked for the V2 party parrot? It becomes really, really difficult. So hopefully by the end of this talk you'll have some ideas. If you're not doing this stuff already, if you're doing this stuff already, please come talk to me, because I've had painful time trying to put all this into some legacy applications, and I'm only learning. This is really some war stories and pains I've encountered. Yes, and it's gone. Wonderful. So, I think it's just the cable. No, I haven't. Let's try that. You know, I have to confess, I'm reading the speaker notes off my phone, and I actually think Google Slides suddenly is really smart, because I moved the slide on and maybe somehow it got confused. Let me try that again. If I have to do this every slide, it's okay. We'll get through it. I have a very good AV guy. I have fed him with Harbrex or Harbo. No? Okay. Well, turn it on, plug it out, kick it was the next option. This is something similar to what I came across in work. I have a browser, Nginx, with the load balancer, Unicorn, the Flask or Django app. You know, if you're trying to offload work, before some of the newer async stuff, you might have used Celery and used a message queue, and maybe Rabbit. And okay, yes, I work for MongoDB, so of course the database is going to be MongoDB. And all of that is fairly okay, but suddenly when you start to scale up, you're looking at over 15 different processes there, and they're all logging. How am I going to track all of this back? So you may half see the sort of hidden transparent image at the back. I'll talk a little bit more about my own woes, but really it boils down to this. So what happens when it all runs together? It's running perfectly most of the time. Sadly, as you add complexity to your stack, tracking down these issues when they're working most of the time make it really difficult. So observability is all about making that type of complex system transparent, and to help you as a developer understand the system. What's broken and why is it broken? What's taking a long time to process? Even a simple question, what's the most common use of my application? So often you'll build things for various customers. They might suddenly like a part, or they might like a monkey meme generator. If they're doing that, how do I know which is a popular one? Should I still support the parrot generator, the parrot API next year? Should I support the monkey API? These are all kind of important questions, but beyond that, observability is trying to help you with performance debugging, capacity planning, and, as I sort of said, problem diagnosis. It overlaps with monitoring, and there's a great deal of confusion between the two. I have a plan. I think the cable is falling out. Started and stopped again. Sorry. Yeah, I think the cable was pulling out. One of the things that everyone should be hopefully familiar with is monitoring. Monitoring differs from observability in the sense that monitoring is there to help you report the overall health of your system. We've long monitored hosts, network, various other resources that we kind of know about. It overlaps with metrics, and we'll go a little bit more into it. So just to recap, the three pillars are logs, metrics, and events, and I'm going to talk more in detail on each of those. But the real difference with observability and monitoring, particularly in the subsection of metrics, is I want to know what is happening in my application from inside my application. So it's giving me measures about how many calls are being made to an API, how many users are logged in. And that's where the focus on metrics is. And it is confusing at times because people will sometimes confuse those two. I will say it now, I'm going to say it a few times during the talk. You should be monitoring anyway, and it's a complementary area to observability. I mentioned white box and black box earlier. White box is really observability type of techniques where we're looking at things that help us understand the state of the various components and the system as a whole. We're looking at metrics, we're looking at logs, we're looking at traces. Black box is your traditional monitoring, your polling, your uptime. I have too much CPU usage on those boxes, or too much memory, I need to add another box, or I need to upscale the box. I noticed that I had been very adventurous in my talk abstract, and I would apologize in that I thought I would have time to dive into both. On mature reflection, writing it, I realized I couldn't mention all these nice things that are in my abstract. So I didn't want to throw them out of the talk, but I did want to cover them briefly. Monitoring's been around for years, and there are some best practices or patterns, or in this case, 3 methods I'd like to flag. Brendan Gregg has a really interesting method called the use method. It's around utilization, saturation, and errors of your application or service. And just to pull back, why would you be concerned about these patterns? If you need to monitor your service, and if you've got customers, you probably should be monitoring your service so you know it's on or off. You also then want to know, okay, it's on or off, how busy is it? These are approaches to thinking about your service or your applications and what I should design for my dashboard and for the metrics I'm monitoring. If you do this, you'll have that at a glance information. You'll be able, hopefully, to more quickly troubleshoot the known error states it can get into. And when I say known, well, if I run out of CPU or I'm almost out of memory, that's kind of a known state. A box has a specific amount of network capacity, is a specific amount of memory, it is a specific amount of disk. You want to track all of those. There are some other methods that are also interesting. The RED method, it's rate of the service, errors of the service, duration of a single trace through it. And then Google have a method themselves called the golden signals, the 4 golden signals. It's latency, errors, and traffic. These are all designed to give that concise, short information. One of the things about monitoring and best practices in monitoring, you're probably going to have a TV or wall board if you're lucky enough in your office for your really important service, and you've a limited space on that. So picking the appropriate metrics and visualizing those help you as an engineer or as a team monitor your service. It would also help then, with your alerting, knowing if they go over thresholds, you can trigger alerts. That's kind of outside this talk, but it leads on to that. A lot of this has come from the site reliability work. There's a big crossover in the DevOps side where engineers are becoming more operationally focused. One of the things with cloud native development is because Amazon and Azure and Google now allow us to spin up clusters very easily, that demo you gave to your boss last month is now in production because he loved it. You didn't have an ops team. They don't really want it until you do some things. So in the interim, if it goes boom, and if it is a tire fire, what should I have around it and what should I do to help me survive and be sane? The best distinction I found between monitoring and observability, and I am not an expert in both, so bear with me. If there are SREs or ops people in here who have more experience, I'm willing to be corrected. I think observability deals with those unknown failure modes. So when I have multiple components and things go wrong, so if I'm provided the context between all of the components and the state of them from the view of the application, I have a better ability to debug it. Monitoring deals with known failure modes, like I said, disk, network, things that are finite, things that if they hit a certain threshold will fall over or won't deal with any more requests from customers because they're simply maxed out. So the first major pillar is logs. I'll give a few examples. Typically, they're structured requests or errors or other messages you have in a text file. Hopefully, you're rotating them. So logs, as I said, messaging in text files, rotating hopefully, so they eventually don't kill your disk. I'm going to make the comment, and I'll introduce some Python libraries to help, that they should be structured. They can be structured, and they should be. I'm excluding specialized, what I call logging software like Sentry or Rollbar. They deal with exceptions, and they deal with them really well. So if you've got a lot of applications that are outside of your company or real customers, if you're interested in the exceptions, using one of those SaaS services takes that away. They do about 10% of the things you'll find in a log, but they do exceptions really well through lovely UIs and help you deal with those. You might be logging exceptions to your logs, you might not, but if you are, use one of those. And also, if you're not, you should be looking at centralized logging. One of the most useful things as you move to more complex systems is to centralize your logging somewhere. So it allows you to keep a historic archive, keep a shorter amount of things on your instance. As we're looking at Kubernetes and containers and spinning things up and down, and they living for much shorter times, actually that instance in that pod, when it's wiped away, what happens to the information on it? It's quite kind of ephemeral. It isn't there was my host, I have procured it through IT, it will sit in the corner for the next 10 years, I will have left 6 months later, and no one will know what the hell is on that box for years. Semi-structured logs look a little bit like this. We were talking about asynchronous earlier. This is an asynchronous example from Sonic. It's a web browser. It's built off kind of the async I/O side on particularly the UV loop framework. It's a really nice web server I've been using a little bit. It's Flask-like. So if you've developed with Flask and are maybe looking to follow up on the earlier talk in this room this morning on asynchronous programming and how does that help me when I'm doing my Flask stuff, which are some people I hope here are doing. Sonic is a really nice way to look at that, and it's deliberately kept Flask-like semantics. In the case of its log, it has 4 interesting pieces of information. It has the timestamp, the process ID, the log level, and a message. It's semi-structured in the sense that they're organized. However, and again, actually going back to the last talk, who here likes regular expressions and writing them? Wow, I have 6. My God, I should leave. I've never loved writing regular expressions because I always find I make a mistake somewhere and I can never find that thing. I've missed something. In the case of this, if you need to look at the log and find specific things, you're probably going to be looking through that. There's no information. I've put a GET request in there, and I've no identifier as to where that is. How would I trace that back? If you imagine back to the first 2 slides I had, if this was just at the outer limit as I move through my system and the other components, how do I track who sent that and how do I correlate that back down to the stack? An aside, one of the pieces of software I've had the pleasure of inheriting, maintaining, and developing involves scraping some internal APIs, so doing a bit with Celery, fetching those APIs, writing them to the database. I have some other programs, and they run tests on those. We use it in my team to create tickets proactively with customers, tell them something's broken, you should fix it, would like to work with you, and flag it to them. Problem with this is I have more than This is a simplified stack. I have more than one scraper. I have a lot more salary workers. As it happens, I have more testing programs as well. But even with this, I have 8 log files to try and figure out where something goes wrong. Starting at the start, how do I track back that request to see for that resource on the API, who requested that, what part of the program, who serviced it in Celery, where did it go through in Rabbit, and then did it actually get tested properly on those other programs? How do I find all that out? I think the simple bit of advice I can give, these 3 steps. Add UUIDs or fingerprints to your requests. So if we go back to the get and post example, if you add a UUID into your log without even changing your log, you will be able to track where that request came into your system and where it went back out, just in the one log. We can use a similar idea to track it through the entire hierarchy of services as well. But even doing that, even if you're just running a web server, allows you to correlate between those 2 points. And Python's wonderful. There's a UUID library. So we just import UUID, generate that, and away we go. We can also use key value pairs and JSON. But before I go, I talk a little bit about spans here. And they're kind of interesting in the context of those complex stacks. So a trace represents the kind of causally related work in that stack. So if I am requesting my party part and it has to go through, and we have 2 load balancers, 3 front ends, 4 back ends, thrown a few caches in there, the database, and we're going to go to an image service to give us a random parse. How do I track that piece of work? That trace gives us the visibility of that client request. So give me a parse. And each of the spans, so if you look at the A, B, C, D, and E, they do that portion of work. So maybe the request to the database in that, the request to the third-party service. So they're logically bundled up into one unit called a trace, made up of individual spans, and they're normally represented as a graph, a directed acyclic graph. I don't really want to go too deeply in this. The Lin Root talk I referenced at the start, and I've also tweeted out now, has a much better Pycon talk that focuses solely on that aspect of tracing. And if you're interested in that, and using things like Jaeger and the other open source tooling around that, you can. They're commercial services you can use to do this stuff as well. I have a link to Jaeger there because I took this diagram similar to one in their docs. But all of them have pretty good documentation sites. I suppose that's one of the things. All of this whole idea of tracing is relatively new. It's been a key instrumentation development in observability in the last 2 years. As we look at microservices, as we move to service meshes, without this kind of ability to understand the whole work across all of those components, the ability for you as an engineer or developer to debug is literally you are going to be pulling your hair out. Going back and moving on, just to say, I said what a UUID is, but just briefly, if you look at the request ID or X request ID that you can pass through in the headers normally, that is how you can track both the trace, and then you can do the spans with other UUIDs, and so you can have basically a parent and children and track them back that way. And it is literally that simple. It is a fingerprint you can use to improve your sanity. Going back, struct log, I haven't really mentioned it. It's a really, really fantastically well documented on Read the Docs Python library, where it allows you to take the information in your log and change it to key value pairs. Everything is basically put into a dictionary, and you can then change that into pipelines. It has a kind of Unix-like philosophy of a processing pipeline, so you can do various things on it. I'm not going to cover much on, you could talk literally for a full talk on that, but it's very simple to use, and it's actually designed to use kind of atop of the logging. You can use it separately, or you can use the standard Python logging and have it supplemented. So in a lot of the code I did, I already had logging, and then I just added this for this key value stuff, which, okay, why? One of the parts I will talk about a little later is log aggregation and what this brings. But it allows me now to look at my logs in a UI and do very interesting questions of the logs. Allows me to look at historic data analysis. I can go and question my services. I'm going to move on just to say JSON instead of plain text. There's a few reasons for that. Primarily though, if you're using log aggregation, like Greylog or Splunk or one of the others, they're somewhat optimized to take in JSON. And one of the key things about all these is you're still maintaining human readability of your logs. So even though you're enriching your logs and giving them more context, you can still read them. And a slight aside now to the second pillar of observability, which is metrics. So this is where we're looking particularly at the application. How many requests were made? How many failures? What types of failures were there? We could add in service checks. So StatsD was one of the forerunners of this. For my research, was reading the ITSI blog. It's in the notes later, where they released this and noted it was 2011, the end of 2011. And I have to say I felt kind of old that this has been taken such for granted now. Everyone's doing it. Like we have the nice ladies who are at the hosted Graphite desk. This is the backbone of so many production applications that, you know, it's if you're not doing it, it's something to consider. And when I mean not doing it, StatsD allows you to have counters, have timing, ask questions. How many of my application requests returned a 500 status code? There's a StatsD library. There's a Datadog library. The reason I'm singling out Datadog, I realize New Relic are 2 doors up. They're good as well. But the Python Datadog StatsD implementation extended the StatsD library and extended it for one very useful and specific piece of functionality. And I think they were the first guys to do it. They added tags to StatsD, which really helped answer the questions like how many of my requests were 200s, 500s. Before that, you didn't have that ability in StatsD, just as the way it was set up. People might have heard Prometheus talks here before, or if you're using Kubernetes, Prometheus is the new thing. It's a time series database. It's very similar. It takes in your key value pairs. The real difference between it and StatsD is StatsD sends a UDP packet every time you have any change to one of the counters or your incrementals every time, whereas Prometheus aggregates it in process and is pulled by Prometheus every few seconds. That's in essence the basics. One of the things I suppose to say is some of these are complex to run, depending. We have hosted providers like hosted Graphite who can do this for you. Depending on your size, if you're starting off and you're trying to add this to your project that's become important, or your startup, it's worth considering looking at using the SaaS options out there who are providing this. You could roll your own as well, but it can be a bit more difficult. So again, one of the differences with logs can go on forever. You can keep them forever. Metrics are designed to have a short period with counters and gauges, and the window will move, so the size is kind of fixed. I'm going to move on because I'm conscious of the time, onto events. Again, this is just a trivial example where I've added the message or event using structure log. You can look at the structure log, read the docs page, and it gives a lot more examples on how to do this. What I do want to say though is, in the case of structuring the logs, I can now associate a specific event and the associated data for that event. So variables, the state of variables, and bring that in to my logging, or beyond that into my aggregator and bring that in for all of my pieces. I've mentioned the log aggregation being made somewhat easier with JSON. And really, to get to the meat of what started to help me was when I started using a log aggregation tool. So one of the best ones out there actually is Greylog. It's a Python one. It has rethought some of the logging format to give more detail to it. But there is Elk, there is Splunk, there is FluentD. There is a whole host of these out there. Some are open source. Some are open source hosted. Some, like Splunk, are totally commercial. What they allow you to do, though, is to use the key in that key value that structured logging gives us, or struct log gives us, as a target to ask new types of questions. So I can ask about how many call counts an API had, how long that duration was. Show me the calls made to the third-party libraries by name for my microservice get part. Those are really, really, really useful to be able to answer, because if I'm going to justify to my manager or to my business unit how important my application is, or my service, if I'm looking for more resources, you actually need to gather that and say, well, this is the case of why I should have a bigger host or more hosts. Previously, without sort of log aggregation, it was very difficult for you to use the real data you actually did have to make those business cases. That's obviously one aspect, and it's kind of under the business intelligence. The other is log aggregation brings all those logs together in a central place. So I had 8 logs. Now I have a tool that allows me to visualize them in my browser. So I'm just expanding on Greylog there. Here's an example. This is visualizing from their own docs, blogs in fact, some AWS flow logs that they pull in, and they're just looking at, when network traffic was going, so when bytes were being moved around. And you could see at about 10 to 3 or 5 to 3, things tapered off. But you're able to see very clearly from that a nice histogram that you could say, well, actually, here's our traffic and here's our periods. One of the things you can do to help this is when you log your API, make sure you include the name of the method you're logging. Adding tags, adding other keys that will help you refine basically those searches. It's something like Splunk has an index, a source file. You can put in a list of hosts. You can put in a word or a key, and then you can do other functions like sort or count on it. And all of these are done in literally one line once your logs are there. You can use log aggregations for alerting. It may not be ideal. There are better ways to do it, but some people do it through Splunk or Greylog, that it's reading the logs, and as it reads the logs, it realizes that in this case, the logs for the last 5 minutes are showing a slowdown in the HTTP responses in production, and alert based on that. There's a few links on each of these. If you want to do structured logging, Steve Tarver and the blogs he's written on them are really useful. Logs and Metrics by Cindy, I'm not going to pronounce her surname, I tried to get it right, but she has a whole section of interesting things. And one very useful piece of software I learned from her stuff is if you are logging, you can use something like mtail, which is a Google program, to convert your standard log into something that Prometheus will take. So if you have logs, and you can't touch them, maybe there's someone else's service, you can use something like mtail and put them into your time series logging database, statsd, Prometheus, whatever. If you were to follow up on one talk out of all of these afterwards, look at the Pycon talk from Lynn Ruth and understand tracing. How we develop software has changed. Microservices brought that change. Service meshes are continuing that change. The sheer complexity that you're going to encounter as we go forward because of all of these wonderful things is enough to melt your brain when you look at, someone will visualize what we're doing in 10 years' time now. When I said 10 years ago we might have had the client, a web server, maybe a database, and your Python app would fall off that. Now it's I would almost call it abstract art. And there goes your sanity. So just literally, I've covered UUID, key value pairs, struct logs, JSON, mtail, metrics, statsd, using a log aggregator. There's a ton of stuff. This is all only just touching the surface. And you still need to monitor. So that helped me answer some of my questions. I still have more. But most of the time now, when things go wrong in some parts of the program, I have an idea. And hopefully you have some ideas from this to go away if you're not implementing these to help you keep your sanity. So sorry for all the AV issues.